Algebra 2, Concept 50, Inferences based on a population. So we're going to wrap up our statistics unit looking at two different types of statistics in a study. Perhaps, let's see. There we go. So first of all, descriptive statistics. Get down a couple definitions. Descriptive statistics show an organization, summarization, and a display of the data. So data is drawn from a study of a population, and it's shown, and then we can organize it, so put it in a range, a list from the least to the greatest. We can find the mean, we can figure standard deviation. That is descriptive statistics. You also have what's called inferential statistics. So this is using a sample to draw conclusions about a population. And then one thing with the statistics is the idea of margin of error. It is a limit on how much the responses may differ from that of the population. Usually the bigger your sample size, and if it is a sample that's not biased or as unbiased as possible, then the more accurate your results are going to be. So let's start with descriptive statistics. So to estimate a population mean, so you've got some data here. It's the number of friends for a random sample of 40 teens using a social networking website. So how many friends they have. Maybe it's Facebook, I don't know. So estimate the population mean. And remember, back from the first concept in the statistics unit, that's mu. So what we can do, you remember, to find the mean is you're simply going to add up all of those numbers. So pause your video, go ahead and do that. There are 40 data values, so find your total, divide by 40, and you'll have your mean or average number of friends. So the total is 11,966 divided by 40. So the average or the mean number of friends is 299.15. So that is a descriptive statistic. Now let's look at example 2, estimating population proportions. And this is an example of inferential statistics, when we look at some data and we make inferences about the entire population. So a student newspaper wants to predict the winner of a city's mayoral election. Two candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked whether they will vote for candidate A. The results are shown in the table. So based on the results of the first 2 sample surveys, do you think candidate A will win the election? So that means we only look here. So this is similar to a real election when results are coming in throughout, usually it's the evening. And so as the evening goes on, you have more and more of your sample size grows. So at first, when we look at just the first 2 reports, we've got 40% in when sample size is 5, and then 33% in. So it looks like at that point that candidate A is probably not going to win. So what you're doing is that you're inferring from the first 2 sample sizes how the results are going. Now, if you continue, and let's say it's throughout the evening and your sample size grows, so more of the votes come in, based on the results of the entire table, do you think candidate A will win? So now what we do is we look, time has passed and our sample size has grown from 5 to 200, and now we see that that percentage has increased. So as more people are voting, now the trend is that candidate A is in the lead. So in this case, it looks like candidate A will probably win the election. Probably so. And this is exactly how real elections are predicted. Because let's say around 59% are in with that simple sample size. And your sample size is increasing. Now, a study is not going to give you perfect results. So what happens is that we can figure what we call a margin of error. And this is a statistic that has been developed or discovered. So when conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. As the sample size increases, then that means your amount of error, or we call it a margin of error, decreases. Now, there is a mathematical formula that we can use. And let's go over that. So, the margin of error can be figured by adding or subtracting 1 divided by the square root of n, and n is the sample size. So, in example 4a, in a survey of 2,048 people in the U.S., 55% said that television is their main source of news. What's the margin of error for the survey? So we can take plus or minus 1 divided by the square root of 2,048. So that means our margin of error is plus or minus 0.022, or in percent, that would be 2.2% above the predicted percent value or 2.2% below the predicted value. So now it says given interval that is likely to contain the exact percent of all the people who use the television as their main source of news. So if you look back up in the information, we have 55 that was our results. So what that means is that we could have our margin of error is 2.2% above, so 57.2%, and then 2.2% below, so we'll subtract, so 52.8%. So our interval will probably go anywhere from, in actuality, that 52.8% of the people have television as their main source of news, up to 57.2. Now do the independent practice problems, pause the video, and then come back and check your work. So on number 1, the mean of the data, or mu, will be 294. So on number 2, do you think the incumbent will be reelected? Probably not, because as their sample size increases, the percent is approaching 42.5%. So again, this is inferential statistics. You're looking as your data comes in and drawing conclusions. And finally, on number 3, a margin of error will be 0.0312, or 3/1200%. So if you add and subtract that to your reported 87%, you'll have a range probably that's realistically going from 83.88% of the people up to 90.1200%.